gonna try up towards the north. They do have the low ground disadvantage though, Lilgun. This could be dangerous in that dire jungle. Azura, he might break the smoke. There are mines around as well to give information away as Varish.
Right.
He does break the smoke on Sanctity. Silence is there. Sanctity, he'll pop the BKB early. Try to fight back Azura on the chase. Will get ruptured up at 1K. He'll go for the man fight instead, and now the blast off is out 4-2-3. He got the BKB in time. Narman, he's the one on the run. He should be alright. Meanwhile, Azura dropping way too low. He's gonna be able to waveform out just in the nick of time, but the chase is going. Azura's in big trouble. Where's this chrono? It's not out yet. They do at least get Sanctity down, but Azura, he will drop as well. Buyback from Narman, and now the chrono. DB turns around again. 4-man chrono's out into the mines. This could be a disaster for Lilgun. They've got to get out of there. They've lost ace 12.
Holy crap.
That's the only one they lose so far. The Tiny is going to drop a DB's on the chase 11. Does he get bashed? Where's the bash? Where's the bash?
Alright, I will go ahead and look at Hacker News for a bit. Let's see what we got. Death by hockey sticks by UCSD EDU. What? Oh. Oh. Okay. So this post is structured as a gauntlet of hockey stick curves. Oh. Okay, it's not exactly hockey sticks, but the hockey stick curve. Alright, interesting. Okay, humans, hockey stick curve, growth, yes. GDP, gross world product, yes. Okay, everything's hockey, sure, why not? Another hockey stick. Global capita per MG, hockey stick, yes. Annual copper reduction. Okay, I get it. Alright, ecological impacts. The extinction rate has gone up, yes. Oh, I see what it's saying. It's basically correlating all the human consumption and what we've been doing with the death of ecology. Interesting. Okay, sure. Alright, is there anything here that is not, like, super obvious? Okay, another symptom of flawed approach to life. GWP, financial gain is... Oh. Okay, here's your thesis. A financial gain in an ecosystem lost almost every time. And so what they do basically is just take all the hockey stick and trends of economics and then throw that against the biodiversity numbers. That's pretty much what this article is. I've seen this before. All I'm going to say is that yeah, there's a correlation, most likely because, you know, every single time there's some economic activity, we consume resources, that probably takes away resources away from life on this earth. So I understand the position, but it's not anything new that I've seen before, or at least that I haven't seen before, I should say. All right. Okay. Yeah, don't worry. I'm gonna get my client on at 8 p.m. So we have 5 minutes left. So if you guys have any questions regarding, like, maybe my last video or something, or you see an interesting link on Hacker News, let me know. Okay, so modern server, modern stacking for self-hosting. Ooh, scaling gets garbage collection. This is interesting. Latest mode. Okay, this is interesting. At GitHub, store a lot of Git data, 18.6 petabytes. Sure, but a lot of it is junk. A lot of it doesn't need to be needed. Doesn't contain at least... This slice of repo is anything that isn't contained in at least one of your repository tags or branches. You don't remove any unreachable data. We do need to remove sensitive information for your repo history. Yes. Okay, so it's cleaning up a bunch of unused stuff. Sure, why not? All this work was contributed upstream to open source project. The tools we built to address them. All right. Object reachability. Okay, an object is reachable when there's at least one branch or tag that you can reach in the object in question. An object is reached by crawling through history commits. Okay, this is actually pretty much the same exact strategy that you might see in, like, virtual machine garbage collection. You basically have a hierarchy of objects. In this case, you have a hierarchy of git commits, actually. So it's the same thing. So we're looking at a sample object graph. For simplicity, I'm only showing commits. Arrows show the commits to the parents. Sure. Blue are reachable, and the red parts are considered unreachable. Why? Why are these unreachable? Okay, so you take the reference heads and only take their parents. Anything that is not referenced or tagged is unreachable. Alright, sure, why not? Unreachable objects can appear in clusters that are totally disconnected from the main object graph. 2 lone red commits in the right hand side. Okay. But then wouldn't these be on a branch? Or would they be orphaned commits in Git? I don't know how you actually get to this state in Git. Alright. Alright, let's see first. Normally unreachable objects stick around your repo until they are either automatically collected. Yep, auto packing for performance. You can manually trigger garbage collection. Okay, cool. Remove unreachable objects, but notice that the date parameter. What does the date parameter do? Objects get permanently deleted based on the last time that they were written. Alright, to fully explain, we need to talk about the race condition that occurs when removing objects from Git. Object unreachable is not part of any branch or tag, so deleting it wouldn't change the unreachable state. Sure. Repacking the repository to remove any copies of the object in question, remove any loose couples of the object that happens to exist, and update the additional indexes. What? I don't understand this one. Repository receives one or more pushes during this okay. So you're reading and packing up while you're getting a write. Server advertises the object at different points in time. Got it. Okay, I understand. So let me review these steps again. Repacking the repository to remove any copies of the object in question. Okay, so you have an unreachable object. You're going to repack the repo and recomputing any deltas that are based on that object. Remove loose copies that happen to exist, and then update the indexes. Why not? Okay. Suppose the server receives that push before proceeding to delete C, then any objects from the incoming push would be corrupted. Okay, so actually I'll go into it here. So if I zoom into this, garbage collection gets triggered, concurrent Git server process incoming update causes C to become unreachable. So you're doing a Git here, and then Git server does some operation to cut C. User initiates a push of local change. User decides to advertise C as part of its reachable set. User's client sends a package that depends on C. Object which depends on C enters the repository. Then object C is deleted from the repository. Okay, so basically this classic read-write race condition. All right, let's APM. I think this is gonna be interesting. I'll read this out later, but let's bring on my client and see what's up. God, it kicked me out. Zoom kicks me out every single time, man. I don't know.
Hello.
Hey, hello?
Hey, Everett.
Hey, how's it going?
Good, man. Doing great. How about yourself?
I'm doing okay. I'm doing okay. Catch me up on your practice. How has that gone?
It's been going good. I think after our last session with throw as many users at your problem, right?
Uh-huh.
Since then, I did the Netflix one. Well, Grokking said do YouTube or Netflix. I went the Netflix route, but on the answer key, it appears to be more geared towards YouTube.
Okay.
I also did the YouTube. No. I also did the Facebook feed and Twitter search for system design. I read the 2 chapters on DDIA, replication and partitioning.
Replication and partitioning, good.
So for the replication one, like it says okay, so a single leader that's common for a lot of web apps, right?
A single what?
They also the single leader one.
Yes.
They also mentioned the leader list, but I really had no way of how to distinguish between both of them and what to choose if ever the question comes up. Because I know for the leader list, it does a write and then it checks again on the reads. So I would say that slows you down, but I think there's more to it there.
Okay. So basically, you're what you're trying to do is figure out whether to do leader versus leaderless, right?
Right.
Basically, it revolves around, and to my understanding, and I could be completely wrong about this, it's about the quorums, right? So if in a leaderless election, you basically have, nodes. Let's say you have 10 nodes, or you have odd number of nodes. I don't remember what the algorithm is. I think not grokking, but DIA lists some weird one, where as long as the majority of the nodes consent on what the source of truth is, that majority gets used, right? And then for leader, I believe that the way it works is that it delegates the rights, but you get an unlimited amount of reads. So the way I would view it, is that you would actually want to see what is bottlenecking you, whether it's the reader rights, and then you would pick leader or leaderless.
Okay, awesome.
Yeah. So I don't really have a good hard and fast rule for that one, partially because when in my head, there's also a lot of nuance that you have to really account for. So, for instance, if let's say we have the illusion of strong consistency, where we're writing to a row, and then while reading into it at the exact same time, committing and then reading it back, while the user ends up reading it as well. It caused a lot of problems, and I think that if I remember right, DDIA goes in depth into how this concurrency can really mess up, and then it gives you a recommendation of leader versus leaderless. Unfortunately, I don't quite remember that discussion. I need to reread that myself again. But
same here.
Yeah.
Okay.
So I'm not gonna this is an area where admittedly I am a little bit weak in, but I would recommend that if you should at least have that discussion.
Okay. Perfect.
So if I grill you on why did you pick leader versus leaderless, you need to have a good answer. But my rule of thumb is where your read and writes. So the way I see it is that if you have a low amount of writes, then you can go with the leader, because the leader is just going to choose where to write to. But then if you have a very high number of reads, then okay, well, any single one of the nodes is going to work, right? But if you have leaderless and you have equal in that situation, then eventually you slow down the propagation.
Yeah.
At least that's my understanding of it. So. Okay. Anything else?
I did some algorithm problems on graphs. I updated the diary entries there. For that one, there's one that I did. It's the next successor. For that one, I took what we did 2 weeks ago, I believe, or 3.
Okay.
And then I kind of tried to sort out all my cards and the logic, right? So for that one, I got really close. So yeah, there's just more practice I needed to on that part. And watch the replay again.
Okay, got it. It seems like you're dedicating quite a bit of time to this. What would you say that approximately how many hours are you giving this per week?
So over the weekend I watched the replays, and then I redo some of the problems or watch that replay as well. And then I started the new problem. So I don't have an exact answer, but every day it's like 3-4 hours more or less.
Okay. Okay, that's pretty good. So you basically spend 20-30 hours. I would say about 20 to 30 hours per week. That's a good amount. As long as it's like super giga focused. I know some people have trouble with that, and I usually have to write the schedule for them. But it seems like you're pretty much on track, which is why I haven't really made a schedule for you for like this is a time that you should wake up, eat, sleep, study, and all that stuff. So it seems like you're pretty good at managing that, at least based on what I've seen and based on the fact that you came pretty prepared. So I'm not gonna harp on that.
Cool. So what would you say? Aim for 10 to 20, 20 to 30. What's like a good number there?
I would say definitely at least 20. I would say bare minimum 20.
Okay.
That's the absolute bare minimum, but I would aim for like 25, 30 if I were you. With like most of the focus, actually I would say probably 50-50 focus between doing problems and then reviewing and analyzing your own mistakes. And that would also include like reading DDIA and all that stuff. So I think people really overestimate the doing problems and underestimate reviewing the mistakes.
Yeah. So yeah, you're looking at like 2 hours doing the problem and then reviewing it. And TDIA, it took me spend like 4 or 5 hours on that thing. So
Yeah.
so
Again,
yeah.
like the fact that it's like so dense, even I can't get the data replication right because there's also fault tolerance that you need to deal with as well. And I don't deal with this on a regular basis, so it's a lot. Every single time this comes up, I do need to reread my notes and shit on this. So I mean, you can also have like leader list, multi-leader, single leader, and each of these comes with their own thing. And I think that you don't really need to know all the giga deep mechanics that I just described until you're at like staff level. So, but as long as you can provide good, reasonable solutions and understand roughly what the benefit and drawback of each is, as how they apply to the problem, you're gonna do just fine.
Okay. Yeah,
but I would definitely recommend you at least try to dig a little bit deep into it, especially since it can't hurt you in your career.
Yeah, that's true. Yeah, with the multi-leader, they did a good analogy there where they say, okay, this is a good candidate for like Google Docs, and you go offline and you go back online, and then you manage the changes, the diffs, and upload that to the leader. So yeah, I thought that was pretty interesting. So that's something to talk about later, I guess.
Yeah, it'll definitely come up if you bring that topic up. Keep in mind, what I would like is for you to be able to talk about like these components they're using, how they serve the problem. But at the end of the day, you're gonna need to maybe dive into like one part or another. You be able to have that in the back of your mind. And I would say, pick your poison, right? It's like, do you want to be a expert in databases, or do you want to be an expert in like caching, or or replication, or some policy? It's like pick something that you're gonna want to really know, like the back of your hand. I can tell you straight up, like if you put me in that situation, I would be, again, I would definitely need to take more time to get prepared, but that's the way I would do it. So okay. So in that case, let's first look at your practice diary, and I want you to, if you have any questions so far about like anything that seemed confusing or something.
Let me see. Yeah, with let me see what I wrote down for the. 1 second.
Yeah, let's see. Interview practice diary. Here we go.
Oh yeah. I had I guess this is specific, right? Like with the Netflix one, they said, okay, let's go with AP. This is after reviewing my notes for my problem.
The Netflix.
And then they said, oh, we can store this in HDFS. But isn't that a CP there?
Okay.
HDFS?
So Hadoop file. They're talking about a Hadoop file system, right?
Correct. Yeah.
So what do you mean? So what exactly is the question?
So, like, okay, so our videos are loaded via AP, right?
So you pick AP. All right. You pick wait, not consistent availability and partitioning. Okay.
Correct. And then later in the chapter, they said, okay, we can store this in HDFS, the files, right, or the videos. So that kind of threw me off there. Like, isn't HDFS supposed to be CP from some searches I did? So that's what kind of threw me off there.
Okay. So what makes you say? Well, let's first dig into that. What makes you say it's CP? How does Hadoop file system work? Because it's a distributed file system, right? So my question is, why? What makes you lead you to believe that is CP versus AP? I want you to give me the reasoning.
Yeah, so my main reason was like, okay, if it's treated as a file system, it should be consistent, right? This is because your date. Oh, wait, hold on. Yeah, just my thought in the back of my mind. I said, okay, this is a file system, should not be consistent all the time. So yeah, I guess the reasoning there was weak, but yeah, that just kind of threw me off there, like, because this was just based off an image search, right? Like they have the diagram of the CAP theorem, and then they have where the different data systems lie.
Okay. Wait, yeah. Let's see. Let's actually take a look at it. So let me open up the YouTube or Netflix one. Okay, so let's see why they say HDFS. Videos. Where would videos be stored? Okay, I would say the top level reasoning is that, hey, videos are very, very big, right? And so we won't be able to have them on a single disk, but instead we need to have them distributed over a large file sources. Because remember, let's take the human problem, right? If we're doing YouTube, we're going to constantly upload videos. If we're constantly uploading videos, then those are very, very big files. That's where our choke point is. So that's probably why they suggested HDFS. But it's good that you're getting into the details. You need to first, if you order to have that discussion, you need to understand how HDFS actually works.
Okay.
And again, this kind of goes back to the details of it.
Okay.
You can at least say distributed file storage system. I think that's good enough for senior level. But if you want to, but for HDFS, you're gonna have to actually say how it actually works if you're gonna name it.
Okay. Yeah. That makes sense.
Yeah. So that's, I'm not gonna fault you on your questioning, but I would expect you to dive into the details. I think, and based on my understanding, is that you have some leader. The way I remember it is that you have some leader, and then you basically ping each section of the file service, each section, via like some network protocol, right? And so either they say, hey, I have the item you're looking for, or the chunk you're looking for, or I don't. And so my understanding is that, okay, you do choose CP, but I don't understand. I'm actually with you on this one. I don't know why they pick why they give HDFS as a solution when it is CP, but it could be my own misunderstanding of how HDFS works. It'd be interesting to go in, but I think you're asking the right questions here.
Okay.
Yeah, it's something about RAID. Was it the RAID policy, RAID 0, RAID 1, or something? But I can't quite remember off the top of my head. But you're right. You're right to ask that question. But you notice here, like in grokking, they don't actually go that deep into it. So I don't think it's not incorrect to ask. So, but it's good to actually get the answer. So okay. Is there anything else here? Because I think right now you're starting to get the gist of like how to approach these things. Okay, so we choose AP, so we're doing entertainment. It's okay if you get the content at a later time. Wait. Did they choose AP? Because if you choose AP, then you actually then you reject consistency, right? So that means that some people will see the video, some other people won't.
Yeah. So I chose AP when I first approached the problem. But when I read that, I did not ever think of doing HDFS. That's why I had that question. Why they would choose something like that?
I'm trying to come up with a reason, but I would say it seems like the reasoning I might have gone with is that, hey, if we make a video available at, let's say, midnight and we have like a world premiere, right? It'd be a little bit awkward to have people have access to it at 12 a.m. and then some other people have access to it at 12:05 a.m. That might be the reasoning.
Okay.
It's like because you're dealing with extremely large files that can be, especially if they're movies, right, on Netflix. That can be several gigabytes. It might take a while for them to propagate. But that might be one reasoning. Yeah. That's of course I'm making up the reason because if you're talking about like some random YouTuber uploading videos, then you can go with AP because it doesn't matter if 90% of their subscribers get the video first and then 5 minutes later other people get it. Yeah, it's like if you're dealing with like small people, then it doesn't really matter. But if you're dealing with like worldwide premieres of videos and movies on for big creators like Mr. Beast, it'd be kind of annoying to like wait 5 minutes for the rest of the people to get.
Yeah.
So, yeah, I mean, again, as long as your reasoning's correct, then it's fine. So it's okay if you get the content at a later time. So yeah, if you're going by that way, that's fine.
Okay, cool.
But yeah, it's but then in that case, and you need a distributed file system, then what would you use?
Okay.
So, but like I said, this system design is really just about the reasoning you take. Okay, so let's see. Think of choke point, number of titles. We have check the choke point before number of titles, or streaming content. I would say the streaming video is more important. Storage is cheap. Pissed off with streaming shit. Not seeing the catalog. Okay, so first things first. I would say the choke point is the video. Like I said, the video themselves.
Okay.
Also, I can take the hit if we're viewing a video later time. The stream quality is different in the middle. So, did you streaming these videos? So you say streaming the videos is the most obvious one. That's interesting.
This okay. So my reasoning for that is users here aren't able to see the video yet, right?
Yes.
But when they're streaming the videos, it works stuck more if they're streaming it and it stops working for them, right? So that was my intuition behind that reasoning there.
Sure, for the service, but when you consider the system as a whole, I think it's more
Okay.
obvious that the videos are going to be the choke point because videos are very big. Not to mention,
yeah,
if we want to
yeah.
stream in different, we want to have different resolutions, right? Some people have iPhones, so maybe they stream it in 720p. Some people have like big HD TVs, so they might want it in 4K, and it's more efficient for us to have different video files, because it goes down by a factor of not 2 but 4. Go from 2K to 4K. And so it's better for us to not only have these video files, but then have lower resolution copies of them, and have those distributed through the blob.
Okay.
So in other words, no matter which way you think about it, streaming these videos is dependent on having these videos in storage to begin with.
Yep.
So that's probably where I would have started first. But your your throughput is not terrible. I mean, not in the sense of your calculations, but I mean that, hey, your reasoning for it, it's just that there's something much more obvious before that. So
that's the titles, right? That you said.
Well, no, it's the videos themselves.
Okay, yeah.
So that's the first thing I would handle. Throughput's not is not necessarily the problem. The amount that your video, what's called the file, the HDFS grows. Not to mention, if we think about the way this content's consumed, can we be a little bit smarter about it eventually? Like maybe movies that are a year old, we can move them to cold storage because they're not likely to be watched again because content these days are disposable. For instance, like shows like Breaking Bad, it's popular, but not too many people are watching it compared to like The Boys. So I would say we can safely move probably Breaking Bad into cold storage.
Yeah. So, another thing about that so I was thinking so you're gonna be able to watch a video, right? And then this goes back to the point of choosing Netflix or YouTube.
Yep.
Since I took the Netflix approach,
okay.
I kind of missed that whole point of you can upload you can upload a video. It can be encoded in various qualities. So yeah, I think I messed up there because of choosing YouTube and assuming that some system admin would upload all these videos, and the main users would be people that subscribe to YouTube there. So.
Okay. So first of all, and no matter what content you have, right, someone has to upload the primary video, right, the full 9,000K or whatever it is, and then you have and then when you start consuming it on the user end, you need to think about with all these different device formats. Again, think about the end user. The end user is going to be consuming it on a bunch of different devices, so we need to have the actual video in a bunch of different formats, right? So you need to have some server that is going to be able to process that. You take the video, you process it into a bunch of different quality versions, which actually you have right here with the media metadata, and then you have a few other things like the thumbnails and whatnot. So that's the approach that I would take. But say again, what exactly was the problem here?
I totally missed the point of because I thought the main users would be people's subscribers, right? I totally missed the people that are in the backend and upload these videos to our service.
Okay, so you missed the person uploading it.
Encoding the videos.
Yeah. It's still kind of the same thing because if you think about it, there's a lot of users like consuming content, and the ratio of users consuming content to the people who are uploading and creating content is very, very small. No matter which way you cut it, I know why you did it, and I'm not blaming you necessarily for that, but it's like if you kind of slowed down, I would say if you slow down and think about how the users actually, like what percentage user actually creates versus consumes, you kind of end up in the exact same thing. I get that you're kind of approaching it from the standpoint of, hey, like Netflix usually has contracts with their own in-house studio and Paramount and whatever, and they buy the content, and then those content gets uploaded to Netflix servers and whatnot. But I think it still comes out to be about the same if you kind of just think about the numbers.
Yep.
That's fine.
Okay, cool.
But again, you have like your reasoning for it, and I think during the course of an interview, someone might correct you.
Okay.
So let's see. Based on what you just said, is your thing reasonable? So first of all, I decided to box this because it has little to do with our core problem. Can move over to user iteration service. Fine. Yes, I'm okay with that actually. Where you can actually move that out to something else. Fine. So you have that. I assume you start with the application server streaming. Streaming has content, media data, and CDN. I think that's fine. But the thing is that when I look at this, what's the first thing you go after? I think you went after the streaming service first, based on what you just said.
Yeah, correct.
Okay, so then let me see if I can find out. Shit. So what's the thing you've actually worked on in your streaming service then? What was the first? I don't quite see it.
Let me see.
Was it the rendering of the videos, or what was it?
I'm trying to look at the notes here. Yeah, it says streaming lots and lots makes sense to have a CDN. We can have the content based on regions.
Okay.
Place CDNs in land countries. Also keep tabs on the user preference based on countries. Yeah, so yeah, I would say I jumped into the streaming here
Okay.
right away.
So, okay, so you went because there's streaming. You then went after the CDN first.
Correct.
Okay, I see why you did that, but I think that, like I said, I'm pretty sure that's a mistake. Because, well, first of all, if you're going after the CDN, then you assume that the content you have is as is, right? And so you're going to be sending this big ass 9K file that could be from a production studio over to, let's say, Russian servers. That's going to take a very long time. And if we're talking about trying to have like those premieres or something, then that can be a huge bottleneck. So I think that's a mistake. Whereas if you did something else, like, okay, we have upload to the server, and then we instead rendered the 360p version, the 720p version, and then distributed those on CDN, that just reverting that would be different, I think. Because at that point, it wouldn't matter if the user uploaded it from, let's say, Latin America or Russia or whatever, right? You could at least handle that processing in the beginning, instead of having every other system in the world handle the processing. You understand, like, how that would change the dynamics, right?
Oh, yeah.
Because, I mean, like, yeah, sure, you paralyzed the rendering, but it's like you pushed a whole lot of data across the wire to do it. And, yeah, don't get me wrong, eventually you will have to push the 9K version, right? But I would say it's probably a whole lot easier and a lot less strain on your resources to just render first and then send each one out, because that way you achieve faster availability.
That makes sense.
Because again, you picked availability, right? So it's like, what is this the fastest way that we can achieve availability? Probably not, because so.
Correct.
Because in a way, you kind of pick consistency, just off of this implicitly, actually.
Yeah. Okay.
So that's you a little bit ignoring the North Compass, and just kind of making sure that what the decisions you made is consistent. But again, I understand your logic. It's just a mistake when you consider what you've declared in the beginning. Okay, let's see.
Okay.
Importantly, we need a logic that will transform the content time to index in a database. What do you mean content time to an index?
Let's say your movie's at 30 minutes. What would be the mapping to the database entries of your data?
Okay. Well, what did you decide your scheme was going to be?
Let me see. Yeah, with that one, let me see. Oh yeah, I just said running time index to perform better streaming and lookups into. But yeah, I didn't go into the specific logic there. Like,
I don't understand what benefit keying runtime over, say, content ID would do.
Okay.
Because when you pick that as your primary index, there's a very specific reason why. You generally want to do joins against it, and you use it as your search, right? So my question is, why is running time going to be the primary over content ID?
Okay. Yeah. So my idea behind that was like, you have to have some sort of mapping somewhere else, right? That maps to the database entries of. The reasoning behind that, I was thinking, okay, a user can skip the video, right? If they move it over to 50 seconds, we have to have a fast way to retrieve that content of your movie.
Oh, I see wait, that would literally mean that every single chunk of video, let's say it's 4 megabytes, you're indexing every single one in the database. That would, but even then you would still need the content ID as like a secondary key or something.
Yeah. Correct.
That's a very questionable choice.
Yeah, I guess did I shoot myself in the foot with this? Because this gets really complicated. I don't know specifically how they implement it, but that's something to read into.
I would say so, but honestly, I would say you focus so much on it. I would probably have. I think it just ends up being it's way too complicated for what I think. You kind of bit off more than you should at the beginning. I always say just start simple. Remember, start with like an ordinary user, and don't like just make sure that they can watch the movie to begin with before they start skipping ahead.
Okay.
I think that you overcomplicate it way too quickly.
Okay.
So start like remember. Let's go back to your FR and NFR. So should the user be able to resume where they left off? Yeah, like, dislike, highly reliable. But I don't see jumping in here.
Okay. I guess that would be user should be able to resume where they left off. But for that, I should have put it out as nice to have because it is complicated.
Well, you explicitly call out jumping. So.
Okay. Yeah.
The thing is that what's the difference between like the difference between where you left off versus jumping is very different, right? Because when you left off, I can literally just say, hey, this user watched this content and had this timestamp, right?
Yeah.
And then let's say the user decides to go out to that and resume that movie, right? You just retrieve the video file, and then just say, hey, start streaming this chunk at byte XYZ because it corresponds to this timestamp.
Yeah.
That would seem like the very easiest way to handle that.
Okay.
So you handled something that wasn't in your North Star, and made that your priority. So that got very dangerous. I think that's where you went wrong.
Yep. Okay.
So it's kind of like I'm ignoring my North Stars here. So that got very complicated. We need logically transfer content from index to a database. This is true for content. Introduce compressions. Yes. So those are your video renderings in different sizes. So fine. Introducing. Yeah, so when I look at this, I think that the source of your troubles is actually you just prioritize the wrong things again. Remember, start simple. Make sure that your basic FRs and NFRs are going to be satisfied.
Okay.
And so, like when you did the delta, what did you observe?
Let me see. Yeah, primarily, let me see. Yeah, primarily it was an encoding server, the thumbnails. But the thing is with the thumbnails, I say, okay, I did specify the multimedia metadata.
Okay.
What I liked what they did here was with this web server, they kind of separated it out.
Yeah.
Because what I did for a lot of my earlier problems, I would just point the user to the application server. But this separates the CDN and the cache more cleaner that way. So I like that one there. But yeah, it's.
Okay, I would be I understand, like, okay, so server and application server. Application server just means that, hey, it's just one part of the experience. Users should be able to upload and view videos, right? There's also, like, the recommendation engine that can come in here. There's also, like, user accounts as well. And those are probably going to be, like, microservices or, like, other servers as well. So that's probably where this is coming from, actually. Because, there's multiple parts to Netflix, right? Not just the upload videos and watch videos portion. And this is mostly like the upload videos and then handle the rendering. So, back to single responsibility principle, although this isn't really single responsibility. This is more like a very limited amount of responsibility, but it still kind of follows the spirit, right? Because what you have here is like you have a user database, right? Server, and the other server here that's going to be generating the metadata, that's going to be generating the thumbnails and then the upload video storage. And so then that leads to hitting the view and image cache from the thumbnails. But do they have the... Actually, I'm kind of curious. Why do they put the CDN in front of the cache? I'm curious. Yeah, hold on. Let me bring up grokking. That doesn't make sense to me. This is a learning... Don't worry. This is like a learning thing for me, too.
Okay, no problem.
Okay. Where would thumbnails be stored? Thumbnails... We have a lot more thumbnails than videos. Yeah, every 5, though. Okay, sure. Why not? Why is the CDN in front? Hold up. Take a look at CDN and caching chapter. CDN is a system of distributed servers that deliver web content. Yeah, based on user geographic. These are blobs. Yeah, why not? And content delivered to the CDN. Can move popular video. Oh! Got it. Okay. So their reasoning is, okay, well, we don't need to have every video in a CDN because we have so much content. And so if we move every video in a CDN, then we basically end up replicating our entire database of videos. And because of the size of the videos, that ends up being a huge choke point, right? It'd be a very big pain in the ass if every single time we uploaded a video, we would have to replicate that across CDN if it gets 0 views. So the CDN is really just for the popular videos, actually. Because with high traffic, then you're going to be able to want to access that. Because a video that's popular in like the US might be popular in the UK and so on and so forth. Like, again, Mr. Beast or whatever. So that's their reasoning. Okay, that makes sense.
I did notice they put a lot of emphasis on the thumbnails from their answer.
Really? Okay.
Yeah, like they have the specific DB there.
Wait.
So I guess that they look at it at the approach from Netflix, right? Like, you load a page, you see a bunch of thumbnails, right? And
yeah,
if you hover over it, you can see all those thumbnails playing, right?
Right.
So, yeah.
Okay, so I see. Yeah. So they basically, let's go back to AFR and NFR. Let's see if we captured that. I personally would have missed that, to be honest.
Yeah, I missed it. Yeah.
Yeah. So I don't blame that on you. I would say that, yeah, if this is probably something that I would have to be goaded by the interviewer when I want to hover over like some video, right? You know, in YouTube, when you hover over the timeline, they have like a thumbnail for every single 30 seconds or 5 seconds or whatever, right?
Yeah.
I don't blame you for missing that because comparatively speaking, the size of the thumbnails you're dealing with is much less than the videos. And I would have only stopped at the videos myself. But it's like, yeah, it's very obvious. If the interviewer brings it up, you should be able to say, oh yeah, like if we want to handle the thumbnails themselves, then we're gonna need to be able to process them as we process the video where we sample XYZ, and then we have thumbnails for each resolution at each different timestamp. And so yeah, because people are going to be looking at the thumbnails for not just the video but also the when we start scrubbing through the video itself, it makes sense to have like the most popular images in the cache. So that's pretty much I think where they're going with here.
Okay.
Let's see. Let's see, thumbnail generator. Yes, that's part of the processing queue, so that's fine. Where would thumbnails be stored? Small 5 kilobytes. Yeah. Page with 20 thumbnails of other videos. Okay, big table. If I remember right, big table is a precursor to HDF, no, to Hadoop, right? Yeah. So I would definitely easily cache a large number of files in memory. Yeah. Okay, that's fine because keeping hot thumbnails in the cache. Yeah, that's exactly what I said, to improve latencies. Okay. I have no problem with this. I understand it. And then they do sharding based on video ID or sharding based on user ID. A user becomes popular, then their videos become popular. Yeah. I mean, you could probably adopt. I would say that.
Yeah, since Netflix doesn't have user IDs, I kind of went with. Let me see what I think. I went with video ID to distribute them randomly. Let me see.
Okay.
Yeah, but if it was YouTube, it would be different. Or no, would it? No.
Well,
because you have popular users.
Sorry, go ahead.
Because if we have popular users, right, they would just flood the cache, one single cache.
Yeah, I guess like if we say like for instance, let's say we're doing Breaking Bad and Better Call Saul, Vince Gilligan might actually be a hot shard. So that I understand that reasoning, but if I think of it from a perspective of video ID, any video can become popular.
Oh yeah.
So I would have thought about that as well. Like if we're counting the quote unquote hot video problem, how can we make sure that one shard isn't super hot? And we think of so that would be my reasoning for it. But I wouldn't do it by user. But I understand if you do it by user. The only problem is that users become really hot and really not very quickly. And so now you have that. Then you might have to start moving users on and off shards, and that can become a little bit dicey. Then again, you kind of end in the situation where any user can blow up on YouTube too. It depends on how you argue it, but I think the better argument is actually by video, because you're more likely to have videos be hot and not much faster, and you don't have to do as much migrations.
Okay.
It just balances the probability. And then I know that they do some deduplication. That one's not something I would have thought of either.
Yeah. Similar to the Dropbox thing. Like if they see, oh, I've seen this hash before, let's reuse it. So.
Oh, let's see. Different aspect ratio. Yeah, this is not something I ever would have thought of. Like, why would a user be uploading the same video twice, or multiple users uploading the same video? Yeah, this is something I would totally miss.
Yeah.
Because like, who re-uploads a Mr. Beast video? I mean, I guess they do, but they usually just chop it up, and they call it their own, like compilation or whatever, and like in order to hide copyright. So this would have completely whiffed over my head. Okay, but this is kind of interesting actually. This is not a bad discussion to have, but I don't blame you for missing it. I would blame you for being misguided in your approach, not following your functional requirements and non-functional requirements. I think that again, that's where it boils down to. So if you have your checklist, I would say, make sure that everything you do aligns with your functional and non-functional requirements. Although I think I mentioned that before in the past.
Yeah.
All right. With that, I think that's pretty good for the mistakes. You ready to do a question?
Yep.
Okay, let's do it. So let me go to your problem sheet. So, like I said, we're going to do a data structure and algorithm just to square it away, and then we'll do a system design after. Let's see, let me pull up the problem sheet. Okay, let me get the timer out. Alright, and here we go. So, suppose I gave you a block of text and a set of strings. I want you to find me the shortest number of words in the block of text that contains the full set of strings. So, what do I mean by that? So, let's consider these three examples, right? You have 1, 2, 3, 4, 5 as here's your set, right? And I gave you a set of 2 and 4, right? So, the string I would want you to return is 2, 3, 4. Because it contains the set of 2 and 4, because it's continuous, right? And the second one here, if I gave you a string 2, 1, 2, 3, 4, 5, and a set of 2 and 4, then 2, 3, 4 would be the string I want you to return, because it is the shortest one. And then the third one, if I have a set 2, 4, 5, and I have a string 2, 1, 2, 3, 4, 5, then 2, 1, 2, 3, 4, 5 is the shortest string. That contains all the words in the set. Does it make sense?
Yeah, that makes sense.
Okay, cool.
For the first one here, for the first example here, do they have to appear in order?
Do they have to be in this order? No.
Like if it's, no?
So for instance, if I were to swap, let's say in this set, 5 to 4, I would still get back the same answer.
Okay.
Does that make sense?
Yeah, that makes sense.
Cool.
Okay, so you're finding me the shortest number of words. Okay. Okay, so I'm thinking here of the brute force solution first. Just drawing out some examples here. Okay, so if I start at 1, it's not in my set. I start with 2. Okay, you want to find the shortest. Okay, so if I start with this one, I see that it's in the set. I advance. I'm gonna basically advance all the way to the end to see if I can find another entry here. So this is my first iteration. I can go all the way to the end here. But I'm thinking, okay, so you found the 2 items that you need. How You find the two items that you found. So I'm here. I'm thinking I don't want to jump into the optimized solution first, right? I want to think it out first.
Okay.
So yeah. So the okay. So let's say I need required, right? Let's say it's a set, and it's guaranteed that the set is unique, right? Or you can have multiple of twos, for example.
No, you'll all the words in the set will be unique.
Okay, cool. Okay, so I have so let's say starting off simple. If word in required set, if the word is in the required set, what you want to do is iterate from current index until you have no more items in required set. Okay. Okay, so for this example, I'm gonna be here.
Okay.
Set equals 2 4. Let's call this scene set. So my goal is to make required set empty. Okay. So if I start off here, if word is in the required set, iterate from current index. And this is our current index. And you basically want to iterate till you find. Okay, so to start.
Yeah, go ahead.
Yeah, so basically, I see 2. 2 is gonna come here. It's gonna be removed from require set.
Okay.
I'm gonna keep iterating. 4 is in require set. It's gonna be removed from here.
Okay.
And let me see. If word is in require set, iterate so you have no more items in require set. So basically, once required set, you have found your minimum, your min string, right? So looking at this other example here below. Okay, so you're here, then you iterate again. Okay. That still gives me the shortest set. So I'm thinking of okay, is there some sort of shrinking that has to occur because maybe I'm thinking a bit ahead here. So
okay.
So the reasoning behind that is like, we want to find the minimum set. That's the key here, right?
Okay.
So let me see in this other example if I can come up with that. 2, that's in my set. So if I iterate, okay, yeah, I see. Okay, this is where we can run into issues when we see the same word again. You see a word that's already in. Okay, so 2 1 2 3. Okay, so here with my algorithm, it's gonna keep going all the way to 5, right?
Okay.
However, that's not the shortest set available.
Yes.
So, okay, so given that, okay, so given that this is leading into a sliding window algorithm.
Okay.
So for this, do you want me to do the brute force first and then go over to the
okay,
optimize?
so let's clear up something. So you started off saying, hey, let's just find the first elements that we find in the set, then just keep iterating until we've seen all the elements. And then after that, we will have our shortest set. But then you realize if there's duplicates, this may not necessarily work.
Correct.
And you've kind of taken a few jumps in logic right now. I want you to kind of slow down and make sure you're logical and straightforward about these things. And we'll talk about it later, but mostly I want you to make sure you don't lose the interviewer. And you lost me a little bit. I know where you're going with this, only because I've seen other people. I know how this problem is solved, but I would want you to, just as a hint, be cautious about how you're doing this.
Right, brute force. We want to check every index possibility. Don't care much. How can I phrase this? We want to check every index possibility. So that entails for index in range length of nums.
Okay.
For index in range, for subindex. Yeah, so the idea is to have a subindex, right?
Okay.
Let me see. Let me try it out. It'll be much better to explain.
I think if you try writing things in like plain English sentences instead of like code like this, I think you might come up with a little bit better explanation. So I really would recommend you try that.
Okay, we want to check every index possibility. Every index start off with a subindex that goes until the end. Keep, once you see that you have all the elements, all the words in the required set, save the length of the indices.
Okay.
I would save it in a min variable.
Okay.
Let me see. So if I start at every index, I'm going to start off at 0. My subindex is going to go all the way from the current index all the way to the end. Then I can iterate. I'm going to go from 0. I'm going to go to 1. Then that one's going to go all the way to the end. Go to 2. 2 is going to go all the way out to the end.
Okay.
So my idea
so you're describing two loops, two nested loops.
Correct. Yeah, correct.
Okay, so you have two nested loops, and then so once you see, so that's what you call your sub-index, right?
Correct.
Okay, so your sub-index is your in-nested loop, and once you see that you have all the words in the required set, okay, save the length of the. Okay, I got it.
Mm-hmm.
Okay, I understand. I understand what you're trying to do here. Okay, that makes sense. It does solve the problem because eventually, you will get to a point where you have like index and then your sub-index or whatever you call it will have every possible combination. Fine.
Mm-hmm.
All right. So my question now is, all right, how do you make this more efficient?
Okay. So for this, let me see. Okay. So the sub-index you're gonna have a lot of repeated entries. Let's take advantage of the sliding window algorithm. What that says, rather than iterating through all the sub indices, you can just have think of it as like a fixed window size of an array, right? You can shrink it and then you can expand it based on a constraint.
Okay.
So let's say, okay.
So my question now is, what is your constraint?
Okay. My constraint is saying, okay, let's expand our window first, and then try to find all the elements that we're looking for, right?
Sure.
Once you have that valid window, let's act upon it and reduce it from the left side, so it shrinks while it's still valid, right? So as you're shrinking it and it's valid, you want to maintain the index size and save it and compare it against your minimum. So once you say, okay, this is no longer invalid, one of the words that I'm looking for, that I'm required, is no longer there. It got popped off. So then you go ahead and you expand your window size again, your window.
Okay, I understand what you're saying. Yeah, sure. I that works.
Okay.
All right. So, how about this? Since you've done that, let's get this one now. Can you get faster? Let me ask that.
Okay. So as far as a pseudocode or coding this already?
Can you get better in sense of, well, you're iterating through. Okay, well, first of all, what's the runtime of the algorithm you just described?
N squared.
Okay. Now, can you get because you're iterating through every single word in that string, right?
Correct.
So now, can you get faster than
that? Yes. So to get faster, we would have to do the sliding window algorithm here.
Well, no. You just described the sliding window, didn't you?
Yeah.
So what do you mean sliding window? Again, I don't understand.
Okay. So I'm confused here. Do you want me to code this up or?
So you just described to me what your solution was, right? And I'm asking you, hey, you are looking at every single word in the string, right? As you do this. So my question now is, actually you described it as n squared, right?
Uh-huh.
Are you sure that's the right way? Are you sure that's the right runtime?
The n squared for the runtime for the sliding window?
Yeah.
That should be n time.
Okay, yeah. So why did you say n squared?
Yeah, sorry, I got confused there. I thought we were talking about the first one there.
Okay, you remember you're the one that's leading the discussion, so you gotta be really, really careful.
Okay. Okay.
So why don't you do this? Since you, how about this? So you basically, I want you to actually optimize on this because I think you can do a little bit better. You might be able to do a little bit better at least, or at least a little bit more cleaner.
Okay, on the optimization. Okay.
You can get a little bit faster. So if you just think about it.
Okay. 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 So our elements in the set are unique. So let's take advantage and say, okay. Because I'm thinking here, if your items are unique in the required set, right? Okay. Yeah. So this is what I'm thinking. So your items are unique. Start off with a window that's no, that's not gonna work because if you have a window of size 2, if you iterate over the string or your sentence, sorry, that won't work exactly.
Mm-hmm.
No, that's not gonna work. So looking at this example here at the end.
So remember, what is inefficient about your solution? Go from there. Remember to always go from there.
Okay, so the question is, how can we optimize the sliding window, right?
Yes, you have your. Okay. What is inefficient about it so far?
Okay, yeah. The inefficiency is it can grow, it can shrink, it can grow again, and it can shrink.
Okay.
So we see. So I'm thinking here a lot. If it's a certain size, right? Let's say it's 5.
Okay.
Let's say this is just thinking out loud. It's 5. You see that the next word is not in your set. So move over. Don't shrink and expand anymore. Just move it in a size of 5. You're only gonna shrink your sliding window until you're only gonna shrink your window if it satisfies the constraint that, okay, by shrinking this, all the elements are gonna still be, my window is still gonna be valid, and it's gonna have all the words I'm looking for.
Sure. So how are you gonna shrink it?
Okay. Let's see. This. Okay. So let's. Okay. So let me go back to the example here. So I'm here. So how would I shrink it? I have to maintain, let me see. Okay. Shrink window. I would shrink the window if, I need to maintain a counter of the words. So maintain a counter of your required words. If the count at, let's see. So by removing the count at x, by removing the word at x, if I see, let me write this out. 2 is gonna be 2, right? I'm just gonna write down the ones that we care about. 5 is just 1. To save time, 4 is gonna be 1. Okay. If the count at x, if it does not go to 0, then we can shrink our window. At the same time, we will decrement the count at x. Okay, so window. Okay, it's an account of your required words. Okay, yeah. So in this step here, I'm thinking of shrinking the window. I'm gonna maintain a count of my required words based on the window I've seen so far. So I see that the sliding window is valid. Okay. So I want to shrink it some more. I see that 2, the entry 2, there's multiple entries. So I can shrink it, I can decrement it, and it's not going to go to 0.
Okay.
So what I do is I would let me move it down below to.
Sure.
Yeah, I would move it over, right?
Yeah, sure.
For the sake of example, I skipped these variables, right?
Okay.
So going back again, if the count at x, it does not go to 0. If the count at x does not go to 0, and the entry at index x is required, then we can shrink our window. So if the count at x is not, and the entry. Okay, so I would shrink it again. I see that. Let me see. I see that I'm.
Wait. If you moved it over to 1, shouldn't you decrease this frequency map?
Oh yes. Yeah, it would be 2 here.
Okay, that's fine. So
it would be 1. Yeah.
Okay,
yeah.
So then you moved it over from 1 to 2. Now what?
Now I'm seeing okay, if the count on x it's going to go to 0, and the entry at x is one of the required, we can't shrink the window, so I would have to maintain the else condition here.
Wait, hold up. So you're at 1, so you maintain the count at x, and if it doesn't go to 0, okay, which is the number of elements between your 2 indices or whatever, then you can shrink our window. But the entry at x, okay, when you say is required, okay, clarify this for me.
Yeah.
When you say is required, what do you mean?
Is inside the required. Let me see what variable we used.
Okay, it's inside inside the set or whatever, right?
Yeah, in the required word set.
Is inside. Doesn't go to 0 and okay, so then now you have 1, so you go to 1, and right. The x count doesn't, and the enter at x is inside. Then we can shrink our window. You can't shrink your window once you're here, though. That's the thing. 1 isn't in the required set, so.
Okay, yeah, that's where I was going at with this else statement here. Else. Yeah, I think what I messed up here was not including all the values in this array inside my
Okay.
inside my counter set. So that just leading to more confusion.
Yeah, I'm going out on a limb here. I'm going to say you don't even understand how your own original sliding window solution works. I'm gonna go out on a limb here and say that. So I'm gonna let's first figure out if you do. I'm gonna ask you to code up your naive sliding window solution before, but I think you can get faster first. So I'm gonna challenge you on that. I think you have no idea how your solution works. So go ahead, right?
Okay, so for the naive one,
your sliding window one. You have a proposed sliding window solution. I want to see you code it, and I want to see if you understand how it works.
Okay. Okay, so let's see. Say minimum window string. Required words, right?
Okay.
Okay, so that the words is just a list, right? No.
Sure.
It's is it okay if we assume it's a list?
For words, yeah, you can assume it's a list. That's fine. I don't care.
Okay.
And then required words is set. So yeah.
I will maintain a counter of required. No. Okay, so okay, so I have the word length. I have the counter required. Let me see. Now I have to let me see. Going back to my code here. Yeah, now I have to iterate over this. So let's say. So let's say the left equals left index equals 0. For index and range length of length. Okay. So I'll write the pseudocode here.
Just write the actual Python code. It's fine.
Okay. Okay. So for index and range word. Okay. So I need to know how many words are required, right? Okay, so the required words is going to be a counter. Then I can maintain a current counter as well. This is including words as well that aren't in the required. This is just to make it easy to step through. Okay, so let me see. So okay, so I add the word to the counter. So current, let me see, counter. Okay, so word, first we have to check if it's in one of our, first we have to see if it's inside what we're looking for. If word in, okay. Word and required words. To counter. Okay, so word. Okay, so have we seen all the words in the? Have we seen all the words in our required set?
Okay, you're gonna take a while with this. Hold on, I'm gonna be in the bathroom for a minute. I'll let you keep coding.
Okay. Okay, words and the word counter at 0, so add so plus equals 1. Words,
Right.
words and
Let's see.
counter.
Okay, so you have add word to counter. So you update your frequency index. Okay, if the word is in required words, then the word counter is equal to 0. You increase the counter. Words found. Sure. Add. Okay. Okay. Okay.
Okay. If the word is, you still want to add the word though to your counter, right? So let's move this out because I want to include all the words, right? Not just the ones that are in the required set.
Sure.
Okay, so
why would you want to Why would you want to add words that are not in your required set? Let me ask that.
This is just to easily step through the code. Because earlier in my example, I got kind of confused by skipping the words that weren't required there.
Okay.
Okay, so I add it. So I added the word to the counter. It's one of the required words, and the counter is 0. So I want to increment the words found, right? And then I increment the counter. So now say this: have we found all the words? Okay. For that, we have to say if words found equals required words length. Okay, this tells me that we have found the words found, right? So now let's say I have my index. Then I have my left index, so that's gonna tell me the length, right? So yeah, I have to maintain a min count, right? Let's say min count equals let's say it's infinity for the sake of this problem. I could just say something like it's just running a min equals min count, and then it's gonna say let's say 0, 1, 2, 3, right? Let's say I'm here 3, so it's gonna be index minus left plus 1, so that's gonna be let's see, left plus 1. Okay. Okay, so that's gonna take care of that. We have a valid window, so let's shrink it. Okay, so to shrink, let's say, okay, so going back to my example, let's see. me just copy this over to this easier. Okay, let's say we're here, right? Okay. Okay, we have a valid window, so let's shrink it. Okay, back to the logic I wrote up here. Let me see. So this is just copying it to write down the code. Okay, maintain a count of your required words. Okay, so this is where we do our shrinking, right? Okay, so while this condition is true, words found equals required words length. Let's say the count on X, it does not go to 0, and the entry at index X is inside the required word set, we can shrink the window. Yeah, I think rather than saying that whole logic there, let's just say while words found equals words length, required words length, right? Because that's much easier than saying this word is going to be at this entry or not, or if it's one of the required words.
Sure.
Mm-hmm. Let me see. So while words found equals word length, we can we have to move the left pointer now. So counter minus +1. Okay, if word in. Okay, so now I'm thinking here. You have to take into account the case whether this word is part of the required words.
Okay.
So if word is in. Okay. Shit. Required set. Yeah, for regular words we don't care. So if word in word in required set and counter word equals 0. Yeah, so here what I'm thinking here is if your word is one of the required sets and the counter goes to 0, that means that your words found has to decrement. So I would have to say words found minus equals 1. Okay. So the case where so now I'm thinking is like, okay, so you're inside this loop where you're shrinking your window, right?
Okay.
Inside this loop where you're shrinking your window, you have to save the minimum count again. So at the start of this, it's valid, right? So let's say, so now I'm thinking here, do I have to move this down here? Oh shit. Yeah, I noticed something. I have the same condition if words found equals requires words length, and also do a while loop on that as well. So what I'm thinking is I can remove the if statement here above, and just shift over the code that I have below, because it's essentially taking care of the same condition there.
Okay.
Shit, how can I move this back on?
Okay, I see. Are you done, or you got other things?
No, I'm trying to move this back.
Okay, it's fine. I get it. I don't care. I understand you're just trying to move it back.
Okay.
I'll just mark. Yeah, this is gonna be. This isn't wrapped in anything, so whatever. I get it. Is this your solution, or you got it, or is there any more?
Let me see. So stepping through this, while we're found, there's still. Where do I move the left pointer? I have to. Okay, so I move here the index, right? Then I have the. Okay, yeah, I have to increment the left pointer, right? X equals 1. So, let me see. Okay, so now I'm thinking of the case of where we said, okay, you're only going to shrink your window if you have all the valid. Sorry, you're only going to shrink your window if you have if you found all the required words in your list, right?
Okay.
Let me see. Okay, so all words found, I saved the length, then I move over the word. Yeah, let me step through this here. How much time were you going to give me on this?
Well, you're up to almost 40 minutes right now. I was going to
shit.
give you 45.
Okay.
So do you
yeah.
think you can get this in the next 5 minutes?
Yeah. I want to step through this. Yeah. Yeah, man, I have a lot of fucking variables, man. Shit. So, let's see. So I have the counter requires word length, current count, words found. Okay. Let's say this is my index, right? Left is here. Okay, so let's say okay, so stepping through this, it's gonna add 2. Stepping through the code. You add word to the counter. If word isn't required word and word counter equals 0, we can increment the words found. Okay. So now index is now 1. 1 is not part of our required words, but you still want to increment the counter. I still want to increment the counter. So let's say it's okay. Going back again. 2. It goes to 2. Word is in required words. It is not equal to 0, so we already found that word, so we can go ahead and skip that. 3. I'm just skipping steps here. 3, it's not in our required word, so we can go ahead and skip that. 4, it is, and the count is 0 initially. We set that to 1, and the words found goes to 2. Okay. So then on our next step is
this time. I'm gonna stop you here actually.
Okay.
Okay. Because we're like at 42 minutes now. What do you think you did right? What do you think you did wrong? I would expect you to get like pretty much done here, and then like spend the next 5-10 minutes getting an optimal solution. If this was a real interview, so.
Yeah. What I did wrong is like I think I jumped around a lot. I didn't have a clear basis on. I didn't have a clear algorithm to start this. Like,
Yeah.
I said, okay, yeah, I can do this in a sliding window fashion. But I skipped the brute force solution right ahead. And then I defined too many variables here. Looking at the code, that just confused me more.
Yes.
What else? Yeah.
Okay. Basically, you had no idea what the fuck you were doing, and I caught on to it, like, I think probably around, like, 18 to 20 minutes. I would say 16 minutes in. Here, let me go ahead and post my commentary, but instead of me, like, going through every single one of your mistakes, I'm going to show you how I would have done the problem.
Okay.
And by the way, I posted these notes on while the stream was going, and I did it in real time, so you can watch the tape and kind of see the notes as I go through. But let me show you how I would have solved it, and maybe you'll understand exactly what's going on and how to solve it. So,
okay.
First things first. Let's go ahead and do the hold up, give me a second. This one just needs to, oops. Do this one, just get those away. Okay. So first things first. Remember, we always start with a naive solution that will actually solve the fucking problem. We never go straight to the optimal one. We always want to have a platform on which to start off on. And I think that you completely missed. This is like, you stumbled a little bit on this. At least you had something that kind of worked, but then as you got further and further, you instantly jumped to sliding window, but you couldn't connect the dots. So first things first, the naive solution, right, is basically, okay, try every single possible combination of substrings. So this would mean, have two nested loops, I and then I plus 1 that goes all the way to n, right?
Okay.
So nested I to I, 0 to n, I plus 1 to n, and then if substring has all, strings in the set, return, add to candidate list, and then, for all, or I should say, like, if substring has all string in the set, then a min equals min of cur min, and then substring dot length or some shit like that. And then you just return the min, or you could just do return the substring, say min str equals min of cur min str dot length, substring dot length, and then assign to min str if substring dot length is less than cur min str. You get the idea.
Yeah.
And then return the cur min str. Okay, this is obviously very inefficient. Why? Because we are trying, we're going through n, which is the length of the string, and then for every single thing we're gonna try the n. We're gonna try every single substring of that. So basically, we have our n squared solution here. And n cubed, you really want to think about how substring contains or whatever works. So obviously this is very, very inefficient, right? So this is two nested loops. And so this is where you should naturally think, hey, wait a minute, I can use a what's called sliding window. Because why? Because the inefficiency here is that I'm trying a whole bunch of substrings that don't actually need to be evaluated. So for instance, in that example I have, right, let's say I have, let's try 2, 1, 2, 3, 4, 5. Right? I'm basically trying, here, and then 2, 1, 1, right? And then 2, 1, 2, and then 2, 1, 2, 3, 2, 1, 2, 3, 4, 2, 1, 2, 3, 4, 5. The inefficiency is that if I'm trying 2, 1, 2, 3, 4, 5, it's going to contain 2, 1, 2, 3, 4, right? And plus the 5, and so on and so forth. So I don't need to keep doing that, and then move this thing over, this carrot over here, and then 2, 1, 2, then 1, 2, 3, then 1, 2, 3, 4, 1, 2, 3, 5, etc., etc. You get the idea. It's just way too inefficient because I'm trying overlapping strings, and this is where the substring, the sliding window comes in. So what exactly does that mean? So what I'm going to do here is I'm going to start at I and then I plus 1, right? And then I'm going to just keep going, like you said, up until I capture all the strings that I'm interested in. So for every single, so my algorithm would go here for I. And then I equals 0, and then I plus 1. If my frequency map doesn't have all the sets, but all the let's say strings in the set, advance the end pointer, right? Because and then so if I doesn't have all the strings in the set, advance the end pointer. and then while advancing the end pointer, let's see. Okay, while end pointer not at end, add element at end pointer to frequency map. Map. If my frequency map doesn't have all the strings in the set, advance the end pointer, right? If it does have all the, if it does have all the string in the set, move up the start pointer, and then until start pointer, evaluate. I should do like I should do evaluate here actually, because at this point I actually have all the strings in the set. So then evaluate with the min str thing you saw up above, right? You get the idea.
Yeah.
Provide the min str as stated above. Carry that over, and then move up the start pointer, and then continue. Rinse, repeat this cycle until I don't have all the strings in the set. So this would cover my the part where I have like my frequency map, which has two has two elements if I'm at this stage, and then what's it called 5 has one copy of it, and then 4 has one copy of it, right? And so once I'm in this part, right, I'm gonna move up the 1, decrement the pointer here, move the start pointer, and if I move up the start pointer, I need to also write I decrement the frequency map of the start pointer of whatever I removed, and then evaluate. Rinse and repeat this cycle. Of course, like this is a little bit sloppy, but you get the idea, right? I'm actually expressing what exactly I'm doing. I'm kind of walking through it step by step. It can be cleaned up, but at least the interviewer is getting the idea here, right? So at this point, I'm just going to look at the start index, end index, and then record that minimum. Okay, this is smaller than what I had before. Great. And then I'm going to go here because I still have all the elements in my set, right? Now I have 2, 5, 4, right? Oh, this is still smaller because if I take the difference between start and end index, it's smaller, right? And then I'm going to go up ahead here and then say 3, 4, 5. Oh no, now update my frequency map. We don't have everything. Back to the top. End pointer's not at end. Okay, great. Let's advance this to the end. Oh, we're at the end now. Whatever. We skip all this. But you get the idea, right? I'm going through it very quickly and I can clean it up, but at least the core idea you fully understand.
Yeah.
And so and how long did it take me? Like 5 minutes? Yeah. So, I mean, I expect people to do this like probably like 10, 12 minutes. Clean up the idea, get a better understanding of it, bulletproof it and whatnot by 15, 20, and then be able to spend the next 10 minutes, come up with a optimal solution, and then so that's at 30 minutes, spend 10 minutes coding up the solution, 40 minutes, and the last 10 minutes, this guy is saying how to scale it out and whatever, 10 minutes. So that's what you should be at. And so now this is what you should have written, right? Now, but or at least that's what you tried to write, but you spent 15 minutes trying to fucking... I don't know what the fuck you tried writing, dude. I think you just went back and forth between your idea in your head and then try and test it out at the same time. And you've seen me write. You never want to do that. The moment you write code is the moment you commit to your idea.
Yeah.
And so, in other words, I would have liked for you to do something like this, plain fucking English, and walk through it. Obviously I have a good idea of like what's going on and how to do it. And then obviously it's me. The rest of it is just me kind of filling in the deets. And then, again, this could be better done, but I'm just doing it quickly for the sake of time here. But I would expect someone who is on the other side to do this much faster. Now, the next thing is, why did I say that there is a more efficient solution after this? Well, what is the inefficiency here? The inefficiency is the fact that there is no difference between testing 1, 2, 3, 4, 5 and 2, 3, 4, 5, because the frequency map remains the same. Testing 1, 2, 3, 4, 5 and 2, 3, 4, 5 is not any different. It'll get me, this is the real answer. So in other words, the shortest substring will ever, and if I just keep doing this, then I'll recognize that the shortest substring must start and end with elements of the set. So in other words, I don't have to iterate through every single string in the string here. I only have to look at the indices of these elements in the set. So what might that look like? So if I have like, a map, a frequency map, or say an index map, let's say 2, which will be 0, 2, and then I have 5, which is 0, 1, 2, 3, 4, 5. So 5, and then 4 would be at index 4, something like that, right? Then I'm only going to iterate through all these, and then look at the smallest, and then the the smallest of all these 3 indices, right? So I'm going to look at all these. So 0, 4, 5, right? So I'm going to have a pointer for every single one of these. So let me actually square this up, just for your understanding. Here. Here, right? So I'm going to look at the largest and smallest between these, right? And then take the delta. Oh, my candidate now is going to be a length at index, 0, 5. And now I can retrieve that string later via substring. I just keep track of the indices, right? So I'm going to push this over now, because this is the smallest. Which represents going from 2 here to 2 here. So now I have a 2 here, right? Right?
Oh, okay, yeah.
Yeah, cool. Now I'm going to push this over. Oh, wow, nothing else. Boom, we're done. But let's say I did have something else. Let's say I had a 9 here, right? Then now I'm going to take index between 4 and 9. And compare it to what I had at 2 and 5. Oh, 2 and 5 is, let's say global min equals 2 and 5, 2, 5. You get the idea. And now we're going to push this, and then we're going to push 4 over until we're out of bounds.
Okay.
But you notice you were able to follow all my logic, hopefully, right?
Yeah, for sure.
So the thing is that you need to be able to do exactly the same thing. Not once did I didn't really write code here. I mean, I wrote some really goddamn shitty pseudocode, but you still understood it, and I could go back and clean it up and make it more accurate and bulletproof it and whatnot. But what you did was basically the exact opposite. You started like with some vague idea, then just said, "Oh, it kind of works" or whatever, right? Mm-hmm. But here, the only difference between what you did and what I did was I actually ran through the code and example and just kind of laid out my idea. And I had a pretty clear idea of how this worked, because all I did was just take the naive solution, recognize what was inefficient, and then just go from there.
Yeah.
Notice that I even stay here, like, go evaluate the minimum string as stated above. As when I said frequency map, you understood exactly what the hell I was talking about. But let's compare it to what you just did. So you had like all this complicated shit. And I'm like, I had some idea of what you were doing, but you weren't able to fill it out because you like, oh yeah, I have a vague idea of what's going on, except you committed yourself to code, and the moment you committed yourself to code like that, you basically sign yourself up for disaster, because what happens if you find out one detail is wrong? Then you have to debug the entire code and fix that shit.
Yeah.
Even at least with English sentences, I roughly can figure out like not only how to do it, I can also, it's very easy for me to fix it. You know, like rinse and repeat this cycle. Oh yeah, I can just put rinse and repeat this cycle until I don't have all the strings in the set. Oh, easy, boom. This is gonna be my while loop, right?
Cool.
And then recommend the frequency map, and then repeat the cycle until I have all the strings in the set. Boom. You know, and this is very easy to translate to code. Of course, I'm gonna run through this with my variable names and whatever. And with my example, just to bulletproof it. But this is a whole lot shorter, simpler, and easier to deal with than your code. And it gives me, and because I ran through it, I have a cleaner idea of what the hell's going on. So you notice like every single step I took here was completely logical. And because it was logical, it was very easy to follow. And because it was very easy to follow, I had a very clear idea of what I was doing. And compared to what you were doing, you're just kind of doing shit in your head.
Yeah.
So that's I think you had this problem like 2 weeks ago where you immediately jumped the pattern. But then you weren't able to follow it up because you didn't have a clear idea. It's the exact same thing. Remember, it's always start with a nice solution, see if it matches any patterns, identify the inefficiencies, match patterns, whatever, and then rinse and repeat that step by step. Always start with a nice solution, start with something that works, identify what the hell's wrong with it, and then if you need to add a pattern on top of it, fine. But everything needs to be logical, order, person easily follows.
Right.
So right now I'm seeing a pattern where you kind of jump the shark. And you end up lucking into a solution. So I'm very curious. Like, can I see your practice diary again for LeetCode? I'm very, very curious.
Yeah. It's it should be on the same in the first tab of the system design diary. Okay. So hopefully for people watching the stream, that solution made sense. And if it made sense to you, then that's good. Okay. So let's look at the Google Sheets. By the way, the runtime just ends up becoming order, order k, which is the size of the elements in the set that we're looking at times the frequency or whatever, times the average frequency. So, okay, so let's look at this. Let me see how the hell you're doing this. I think you overcommitted on the DP. You might have overcommitted on the DP actually. Okay.
Oh no. Oh shit. Use Qt. Okay. Remember what I said. It's all about bulletproofing your approach, and I don't see anything here about your approach. All you write here is like, how do I describe this?
Like facts, right? Like,
yeah.
Basically remembering shit.
Yeah, you didn't describe anything that's actionable other than, oh, memorize this one thing in this one particular situation. Very rarely is that the case. Remember, if you keep doing this and you keep saying, oh, I have to memorize this, I have to memorize this, I have to memorize this, chances are you're not going to memorize everything, right?
Exactly, yeah.
So, in other words, I see this as a, yeah, you really screwed up. You did the same exact thing that Jay did, actually, where you basically blamed, this is what I call blaming the problem.
Yeah, okay.
And you decided to memorize, oh, next need to adjust loop until you have node count and less than 2. That's not the question that you should be asking. The question you should be asking is, how the fuck do I avoid this mistake to begin with? Yeah, so this is really fucking, like, this is really bad, actually. Shit. Ugh. So, okay. Well, let me think about how to process this. I was expecting that your lead code would be much more solid than this, but I guess not. We might have to split the time up 50-50 between lead code and system design, and I might have to ask, and you're going to probably put in extra hours.
Okay, that's fine.
Holy shit. Yeah, this is bad. So, okay. We have 20 minutes left. Okay, let's do this. There's not enough time to do a system design problem. So let's table that for now. What I want to do instead is to try to come up with a game plan for you and end a little bit early, so that way you can execute on it. Because your interview is what, the 28th?
No, the 30th. And then for Google, I can reschedule that, so no problem there.
Holy fuck, yeah, please do. You are nowhere near ready for the lead code.
Remember,
system design and lead code for senior level is 50-50, and for L4 level, you're probably like 60, like two-thirds coding, 1/3 system design.
Yeah, exactly. Yeah.
So the holy shit. Okay. So let's do this. Let me see if we can figure out a way to bail you out of this. I got sidelined by that. Holy fuck. Okay. So 9:30 Amazon, 10:15 Google. Okay. So let's do this. 9:13. Okay, yeah, we have that. So let me boot up a practice sheet for you.
Okay.
Hold up. Let me get that up. Practice diary. Okay, cool. Let me insert a new sheet.
Okay.
Oh shit. And then let me pull out mine. Okay. Okay, so we have. Let me copy this sheet. Actually, this is a good one. Okay, so I'm here. Oof. Okay, so yeah, we're gonna need to be a lot more strict about this shit. If we have this little margin of error, we're gonna be super strict. So, okay. So right now we are at, what was it, 9:13. So let's say 9:13 to 9:19. You're going to start from. I get the feeling we're going to start from scratch for EPI. So remember, you can watch like a few videos that I have, and like even the guide. I have a guide on how to do the thought delta. You really want to bulletproof your approach. Remember that checklist that I made you do for system design? I want you to do.
Yeah.
I want you to do exactly the same thing for lead code.
Okay.
You want to bulletproof that approach. So I'm going to say, homework. Do split 50-50 between lead code and system design. And for now this week, we really need to focus on lead code. Holy shit. So make sure you bulletproof your approach. And yeah, in my guide there is a little section on like the approach and the question that you need to ask yourself for self-evaluation. I would recommend you read that. Remember, start with naive solution, keep what works, I acknowledge what is inefficient, and make sure you get your runtimes right.
Okay.
Right, and then iterate over your solution and test This is the basic approach, but you're gonna grow it yourself. And really, yeah, you're gonna basically grow it yourself and your own way of doing it. But this is this is your bread and butter. No matter who you are, you're always gonna have this core. But the questions you ask yourself to grow your solution is going to be different from person to person. So in this case, let's do this. 919, 920 to 10 to 927. Holy shit. Okay, so no DDIA. I'm going to kill that. Okay, the strings, linked list, leak code, recursion, tree problems. This is the pool of questions that you're going to ask you're going to go from. Okay, I'm gonna leave these blank for now.
Okay.
But yeah, these are basically the topics I think we're gonna work on. But let's start. Yeah, let's start with strings, linked list, and recursion and tree problems, and then we can move on to array and strings and whatever. But this is gonna be not even leak code. Don't do leak code actually. Recursion tree. There's a chapter specifically for that in EPI, and I really want you to focus on EPI and really look at their what's called
their approach. Yep.
Yeah, their approach. Really bulletproof your approach.
Okay.
Okay. Next thing. Because of how rigorous it's gonna be, I'm basically you are gonna have no free time. I'm gonna tell you straight up right now. Okay. So what time do you get off work? Let me ask that.
Around 4.
4? All right.
Yeah, it's like 8 to 4.
So you get off 4. Okay, hour 30 block here. So you're a PST or EST?
PST.
Cool. All right. What time do you usually go to bed?
11. Let's say 12.
12. Okay, let's say 12 here. And then what time do you wake up?
Around 7:30, 7 to 7:30.
Okay, 7:30. All right. Okay, I'm going to say 8 to 4 is your work time. Do you have any other outside obligations?
Nope. Just let me see. Just on Saturdays from 9 to 2, I'm busy.
Okay, 9 to 2. Fine, I'll give you that. But I'm going to tell you straight up, if you know what's good for you, you're gonna get rid of it.
Yeah, for sure.
As soon as possible. Okay, let's say blocked temporarily on Saturday. Okay. And then I'm gonna move your dinner up to 6:30, and then 7 p.m. 7:30. I'm gonna give you this block, hour and a half. The space means a break. Go shower, do your thing there. Yeah. So this is like your weekday schedule. Weekend.
Mm-hmm.
I like to keep the schedule consistent here.
Yeah, Sunday is free. No obligations there.
Okay. And then we'll just do this. And then we'll block an hour in the morning for studying. Or actually, yeah. I prefer you get like a little bit of that done.
Yeah,
but basically, what I want you to do is basically take the schedule as like your Bible for the next however many weeks. There really is no wiggle room for like screwing up. And if you have any questions like, hey, am I doing the thought delta correctly? Then you want to ask me. I think that in the previous iteration of your sheet, I had an example of the thought deltas. Really, and if you look at the past streams I did with Jay, you can find the playlist. You'll notice that I basically grill him on the question that you need to ask yourself and the approach.
Okay.
And so remember, it's always about, hey, how do I make my approach better? How do I avoid making these mistakes? What questions do I need to ask myself in my problems in order to set myself up to avoid it? Sometimes it's going to be memorize this one fact. But if you have to keep memorizing facts over and over and over again, then that's not very much of an approach. That's really just you memorizing problems. And notice, like, all I did for that is, like, oh, what's my inefficiency? What am I repeating over and over again? And then all I did was, like, kind of just group the code into manageable blocks. It's a very simple strategy that I did. And, of course, there's a lot of things that are implicit in here, too. But mostly that should have been in your approach.
Okay.
Okay. That said, I gave you the schedule for leak code, not leak code, but split your time between, not leak code, but Elemental programming interview and system design. And
So
I'm gonna mostly I'm gonna mostly groove you on leak code this week actually.
okay. So for the API, because I know they separated it by like term and week. What problems do you want me to do for those chapters?
There is a little schedule at the top that says, "Oh, my interview's in 1 month." Do the 1 month schedule.
Oh,
But if you're
okay, 1 month. Okay.
yeah, 1 month schedule. But I would recommend if you get through it early, do every single problem.
Okay. Okay.
This is bad. This is bad actually.
Yeah.
I'm sweating a little bit. Okay, but that's my recommendation to you. I think that remember, it's always about the approach, bulletproofing your approach, and making sure you test your shit before you commit to it.
Okay. Okay.
Yeah,
Man, I think a big thing is like when I'm thinking of like the solution, I kind of mix in the English words with actual code. So I that's something I have to change for sure.
yeah. I mean, don't get me wrong. I did that in the what's called the example I did, but like where I have I equals 0, I plus 1. I have a little bit of it in there, but but for the most part, it's mostly all English.
Yeah.
So, yeah, I'm gonna. So that means that when I next see you on Thursday, I want to see some. Was it your sys design checklist, and then your what's called the data structure and algorithm checklist. I want you to start growing those.
Okay.
Okay. That's basically it from me, and I would recommend you you rewatch the stream a little bit and you kind of look at it from my angle and kind of see like what mistakes you are making as well. Because it's one thing to read, oh yeah, I ever wrote this at XYZ timestamp, but as a whole, it's gonna burn your brain once you kind of see it from what I'm seeing.
Yeah.
Okay. Any final questions? I think I'm gonna turn it off early and give you time to do leak codes, or not leak code, but EPI.
Okay, so you said to I guess look at the J videos too if I have time. You said
I would say here. Let me reorganize some of the videos because I think I haven't added some to the playlist just yet. But I would say watch the last probably 3 streams on like 2x speed or something like that. I'll skip around to the part where I look at his practice diary. I think that's within the first 30 minutes. You only really need to look at that part of like the questions that he's asking himself. And let me know if you want his practice diary. I'll share it with you. That way you can kind of see the questions that he's asking, and you kind of see like how my feedback about his practice diary grows over time.
Okay, yeah, that'd be helpful, man. So I can share that.
So yeah, I will send that to you off the stream.
Okay, cool.
All right. Any final questions?
Nope. Just basically change the approach and come up with a checklist and practice this stuff.
Yep, exactly. And make sure you really, really start to think about the what's it called? The way you think about the leak code problems and your approach. Really criticize from your own angle and see, hey, yeah, does everything I'm saying make sense?
Yeah. Okay. Yeah. So the Google, I can reschedule that one. I don't know how far out they'll let me. But yeah, that's the one we want to aim for. So yeah. I still haven't set the date. So as we do these, we'll do that.
Matthias, Russell, or Jay, the last few sessions where we do lead coding, I think the first 30 minutes is going to be fine. I would say at least try watching those during your lunch break, if you take one.
Okay.
I think that's the best way to do it, or during the breaks that I've set aside for you. Don't do it as part of your study. Do it as part of hey, this is kind of like what Edward's doing, what Edward's expecting from me.
All right. That makes sense. Okay.
Okay, cool. All right, then I'm going to let you go.
Cool. Awesome. Thanks, man.
All right, thanks. Later. Okay. Just let me turn off the... Okay. Any questions from the crowd? Edward. Okay, Crow Sue asks, Edward, what should I expect after passing the code assessment of Google? Any insight you're willing to share would very much be appreciated. It's early career SWE position. Thank you. Basically, if you pass the coding assessment of Google, you should expect an invitation to an onsite. Or they might do a phone screen. It's either one of the two. That's it. That's all I can say. It really depends on how well you do. If you pass the online assessment with flying colors, they just might go straight to the onsite. But yeah, that's the only thing I can really say. Any questions? Any other questions from the crowd about what you just saw? It's yeah, man. I'm not gonna lie. That gave me a little bit of a heart attack. I thought he'd be a little bit better, but about the destruction algorithms, but goddamn, I was not expecting that. I will put on some Dota while we wait, and then I will close it out if no one has any other questions.
Which is a little bit greedy. I think Cirque is going to have to try to play around the early threat, have Teehee have a lot of presence in the first 6 minutes of the game, just apply that pressure that you want to, and kind of hold back the side of NGX and build up that way, because you can escalate really fast off the back of those pickoffs. Otherwise, you're waiting for blink timing on Losify. Ken's just going to be farming up. JG as well. Travel's blink BKB. More than likely going to be necessary. I think overall, when you look at NGX's draft, it's just very well covered. Like, you've got Omni Knight to save. You've got this combination with the Chrono, with the DP, and with the kisses out from Jocam on the Snapfire. So you do have a lot of play there. And I think overall, a core-to-core matchup of AM versus Faces Void. I mean, Void down the line, if he catches you in that Chrono, there's no play. Like, there is no stopping it from the side of Xerxia here.
It's going to be very problematic here, I think, for Xerxia, but we'll see what they can get done. I mean, they did pick this AM, this Prophet, into the Void, so it seems like they're confident enough to try and make this draft work. Again, these guys beat TNT in a best-of-1 yesterday, so maybe off the back of that momentum, they're feeling a little bit good. NGXC, on the other hand, losing 2-0 to Polaris Esports in the upper bracket round of 1, not feeling amazing right now. Though you would have to argue NGXC is looking to be the favorites going into this matchup, just, you know, based off the rosters and the organization itself. We'll find out, though. Again,
okay. They invited me to on-site, but don't really know what to expect. What was his mistakes? What was his mistake that scared you? Basically, when I first talked to him, he said his leak code and data structure algorithm was pretty good. And based on his diary, it seemed like it was. And I kind of took him at his word for it, but I think that was probably my mistake. I keep making that mistake out of naivety, because, you know, like, if someone follows my content and follows it, I think that in general they tend to do pretty well on things. And given that his deadline was so close, I think that also pressured me into focusing more on system design. But I kind of let the leak code thing slip. That's kind of that's my fault. I probably should have grilled the leak code a little bit more, honestly. But if you're going for an L5, then both of these kind of get weighed equally, so it's a little bit hard. So the mistake is basically the naive approach to optimal approach, because if you can't nail that for leak code, you're not gonna, or like data structure and algorithms, you're not gonna nail that for system design at all. And I think that I was starting to see that pattern, is that he was kind of just jumping the gun instead of trying to go from simple to complex. And I should have caught on to that, actually. I still have questions about asking yourself question checklists. It always seems so abstract. Yeah. So it is very abstract. It's an abstract notion, right? So if you think about a solid implementation would be, if I had the problem, right? It would be, hey, did I make sure that I used, I considered the naive solution? Did I do did I identify what my inefficiencies were? And then there's also smaller ones, such as if I'm doing recursion, did I separate it out into base case and recursive case? Did every single chunk of code have single responsibility? Again, these are abstract notions that don't make sense to other people, but make sense to someone, who is the actual practitioner in usage. It's like, I want to compare it to kind of like an airplane safety check, where you want to make sure that the check engine light, the engine lights and the landing gear and whatnot, and every single knob is completely right. Except for the fact when it comes to problem solving, everyone has their own different approach, but the core logic is going to be exactly the same. And so that is where the checklist comes in handy. Now, of course, again, like you said, it's abstract. But if you asked Warren Buffett to come up with a checklist for how he judges investing, he's going to have a few basic ones, right? But a lot of it's going to be an X factor that he's learned through trial and error. And that's really what we're trying to nail here, that X factor. What would a potentially lighter schedule look like if you don't currently have any interview schedule, but don't want to cram like a maniac in space for a month?
TI-11, because they were against Miz, but Miz could do nothing to help them out.
A lighter schedule probably would be like 10 to 15 hours less.
Some aggression in here.
I think that's basically it.
Coming out with a
and that can mean like that would be an additional like 2 to 3
once you
hours of
melt
free
the
time
mana
every single day.
on these heroes, I mean, that added
And that can make
slowdown
a
on
world of
AM
difference to
does mean
people.
You've got a lot more presence. It's much easier
When
to
I look for
chase
deltas, it
down.
always seems like tricks or knowledge gaps.
There are combinations
Yeah,
down the
that
line here
usually
for
means
NGXC.
that you
Once
are
Jokam has the value point
you're
of
missing.
Cookie,
You're probably missing the bigger
you can
picture, because
tie that
chances
in with the
are
Spirit Side
there's
and
just
bring
one
out
or two questions that you need to
This
ask
is
yourself
a good
in
chase
order to
point
put yourself in a position
and just look
to
for the
see
threat,
those.
but at that same point,
So,
again,
for
might be
instance,
value point
one of the ones I really liked is the
Magic
spiral
Resist does
ordering
ensure that
of a
you're not
matrix.
just gonna be able to melt through
And in the
Oh,
book,
he's doing a great
they, you know,
job
someone might do like 4-4 loop, like a loop, and then
for
a loop, what's called a loop to head on the top, right, left, and then up, you know, and then chunk it down that way, right? And so the way they do it is that they have an enum that represents the direction at which they need to go. Because if you abstract the idea and say, hey, I'm just going to keep going, and then once I hit the end, I'm going to change direction and change the enum. So it goes from like right direction to down direction, to left direction to up direction, and then keep going. So that's basically the trick right there. But the way you can ask yourself that is, how can my code be a lot cleaner and simpler? Am I doing a lot of repeated work? Am I doing things that can be simplified? That's really it. And then from there, if you ask yourself that, it's like, oh yeah, that's then if I just think of each what's it called, each iteration, each for loop as a direction that I'm heading in, because you know, for loops in general are just like, you know, tick 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 tick, like one after the other, then it kind of makes sense. So I think that that's a pretty reasonable thing to do, actually. At least that's in my book. But I don't know. Like I said, it makes sense to me, but it might not make sense to other people. It's just the way that you ask yourself the question. I aced the coding assessment, but I am terrified of what to expect for the next round. I am not taking any class this semester. Do you advise me to split between EPI and grokking? Time split? Grokking you should be done and dusted with. That's the thing by the time you hit EPI. So if you have done with grokking, do EPI. That's the thing. I think people keep like just stopping at step 1. I don't know what it is. It's like, is there something wrong with my guide? I'm pretty sure, like, in my guide, you just read past the first paragraph. You say, hey, do EPI after you're done with grokking. Is there, I mean, maybe I need to revise the guide. I keep getting this question.
Lacrity doing very well right now mid lane, John. 25
all right.
or rather 26 and 0 on that Storm Spirit. So
Yeah, you know what? I'm gonna add a. Hold up. Let me just edit the guide and write in the very, very top, or not in the top of the section, that you need that EPI should be. You should do EPI, not just stop at grokking.
Just yet there, Mike, but Alacrity is holding that lane low. Just
I
back
meant
to...
the last
Yeah, I mean, I even have a how to study grokking. Okay, so then, let's see. Let me pull this up.
All right, you've got that, and still, you know, he's holding his lane again.
I will mandate you pick up the following 2 materials. You're the best. You must do at least before you go to EPI.
Pretty good. Clear out.
Do not stop
This
at
is a bit of a slower
just
game.
grokking.
That's to be expected from
Grokking
these kinds
is
of lanes,
just
so NGX
step
have a bit more
1
presence
of
at top,
the
seeing
process.
that committal
There.
onto Ken. He is
Now that I've highlighted it and it's in bold, you guys have no more excuses. Okay?
Just forced to play
Okay.
the farming game up against the AM, at least in this lane, and that always.
It's only hard enough. My fundamentals aren't there yet. Don't scold me. I'm trying my best. Dude, I know. I get it. People are just trying their best. And I'm just trying to adjust to, like, what I see. You know what I mean?
Onslaught away.
So.
No bashes to come from in your drink to put an end to that. Even with the trample, it's kind of hard because again, Boom Boy with the Heavenly Grace, he just tanks you up. He gives you that extra regen, and suddenly trample just doesn't feel that good anymore.
Yeah, it's certainly not that start we'd expect from the Primal Beast. I mean, this here is a lane dominant.
Anyway, the fundamentals come with
Doesn't
practice.
feel that way.
And like I said, you just need to just focus on, hey, make sure
Time
that
allowed to give to
whatever
it.
you're
Trying to
doing,
shove it
your
in,
approach
he
is going to
does
be the
get
king.
here to
That's
try
the way you need to
something.
think about these.
Is out. Alacrity gonna put an end
Is
to
that?
it with the vortex,
I'm going to stop the
a very
stream.
nice fish
Thank you all for
in the
joining me.
mix with
I'm
Dukan.
going to
Can't
be
get away. Alacrity
streaming
still
again
trying
on
to fight.
Thursday,
JJ
8 p.m. Pacific
wanting
Standard
the
Time.
trade, cannot
So
afford to
hope you all
stick
join
around.
me for that. We'll
Back
be looking at the
his way
replay
out.
analysis.
Nice pick off there from the
And
side
yeah,
of Xerxia.
I will see
Because
you
he
all
would've
later.
preferred to find Alacrity with that rotation. Fortunately, they had to settle for the snap